Hey everyone, welcome to the final exam review for intermediate algebra. This is Nick Jacobs, your intermediate algebra instructor here at Yavapai College. So this is going to be a little bit lengthy of a review. And again, you don't have to watch the entire thing. If you don't want to, you can kind of skip around. But what I will say is I'll spend the first couple minutes here kind of going over what your final exam will be covering. And then again, if you do have questions about that or anything else regarding wrapping up the semester, please let me know. So I did want to mention, first of all, that your practice final exam is graded. Okay, so your practice final on my lab is graded. Okay, and that's because I want you to go through that practice final exam and some of the topics that maybe we haven't seen in a couple months or something like that, right? So, I think that'll help you overall in the long run as you study and prepare for the final. So your final exam, it's going to be 32 questions. And this is the breakdown, okay, of how many problems we'll have from each chapter. And on this exam review today, I'm going to go through 24 problems. And they will all be similar or kind of on the same topics that the final exam problems will be on, okay? So basically, 3/4 of the problems that I do on this will be very similar to the ones that you'll see on the final. So let me know if you have any questions on any of these that I cover. As with the other exams, you guys will have 3 hours to complete the final. And you do have to submit your work on the Canvas, okay? So when you do decide to take your exam, good luck. And again, let me know if you have any questions before you take it. All right, so what I'm going to do here is I'm going to go through some key concepts that you'll be tested on for the final for each chapter. And when I list these concepts out, you will have a question on all of the concepts that I list. Okay, so I might not go over problems from each of these concepts, but you will have a question on that. Okay, so if I list here factor out the greatest common factor, I will have an example here on that, but not all of these I may not have an example. So just so you know, these are the concepts that will be that you'll be tested on for chapter 6, and I'll do that for every chapter here, and then I'll go through some examples from those chapters. So that's how this review is going to work. So this is question number 2 on the practice final exam, and again, your numbers are going to be different probably than mine, but the topic here again is factoring out the greatest common factor out of an expression. So the directions here for this question say identify the greatest common factor, then factor the expression. So 2 different things that you have to do. So first identify the GCF, then we're going to factor. So how do we find the greatest common factor? Well, if we remember here all the way back to chapter 6 in September, or maybe it was even August, we can list these 2 expressions or terms out, I should say. And then what you can do is you can kind of list the multiplication for all of those. So this would be 3 times b times c squared is c times c. And then 3 times c times b times b. And then what you do for the greatest common factor is you look for pairs of each of those. So we have some 3s. And here we have a b, and then we also have a c. So we have a 3, we have a b, and we have a c. That is going to be your greatest common factor. Okay. Now that we've identified it, okay, what we can do here, I'll just rewrite this original problem. We take out a 3bc from each of these things. So if I take out 3bc from this first term, 3bc squared, I just have a c left over. And then I keep this subtraction sign. If I take out a 3bc from this one, I have a b left over. And this would be your factored form. And you could check that by multiplying the 3bc into the c, and then also to the b, and seeing if you get the same thing. Question 5 on the practice exam deals with factoring trinomials of the form ax squared plus bx plus c. Okay, and I told you guys that you could either group these, and that's kind of the way that I taught, or you could guess and check. So factor this trinomial. So I'm going to do this by grouping. Again, you can always guess and check if you're more comfortable with that. That's actually the way that I was taught, but I will teach this grouping method. So what we do here is we take the first. So first of all, you have to make sure it's in order, right? From greatest exponent to least exponent. And once it's in order, you can take the first coefficient and multiply it by the last whole number. So we multiply 4 times 9, and that gives us, sorry, I don't want to break that up yet. That gives us 36. And what we're doing here is we want factors of 36 that add to a negative 15, okay? So if I break down 36, I'll just break it down all the way into different factors. And we're looking for 2 of these that add to negative 15 that multiply to give me a positive 36. So I can see here that if I make negative 3 or 3 and 12 negative, that both of those added together give us that negative 15, but also that negative 3 times negative 12 is positive 36. So these are the 2 factors that I want in order to do what we call splitting this middle term, so that I can group this. And it doesn't matter what order you put the 3 or the negative 3 and the 12 in. I could put the negative 12a first, or the negative 12a after the negative 3a, like I did here. So again, you're splitting this middle term. And now what you can do after you do that is you can group these 2 parts. Okay, this is a 12. And then we can factor out a greatest common factor from each of these things, and then use that to factor in the end here. So from 4a squared minus 3a, I can take out an a, and that leaves me with 4a minus 3. Keep this middle sign here, and then I can factor a 3 out from each of those. And again, I'm left with 4a minus 3. And the whole point of that is to get these 2 things to match here, the 4a minus 3. So once I do that, that's going to be a common factor that I can take out. And then I'm left with the a minus 3. And this is your factored form. And again, you can always check it by FOIL, right? So if we check this by FOIL, we multiply the first 2 terms, we have 4a squared, and then 4a times negative 3 is 12a. Negative 3 times a is negative 3a. Those are the inside terms. And then negative 3 and negative 3, our last terms, are positive 9. And that does FOIL out to give us what we originally had. So it checks. All right, and then another question here from chapter 6 is factoring a difference of squares. So if we remember our difference of squares, that went something like, if I had something that was a perfect square minus another perfect square, I could take it and I could have a minus b times a plus b. Okay, and so the first thing you have to do here is if you get this expression with 2 different terms in it, and they're both perfect square terms, then we know that it's a difference of squares. And so basically what I'm doing here is I'm asking myself, well, what would the, if this whole thing is your a squared value, and this 81 is b squared. So if 25x squared is a squared, what is the a? Okay. So basically what I'm doing here is, what's the square root of 25x squared? Well, that's just 5x. Okay, and what's the square root of 81? Well, that's just 9. Okay, so a is 5x. And if you want to think about it as b is 9. And then what you do is you put that in factored form. So we would have 5x minus 9, and I'm following the formula, and 5x plus 9. And again, what you could do is you could factor all or FOIL all this out, and your middle two terms, when you FOIL it, should cancel, but you should be left with the 25x squared minus the 81. All right, this is number 10 on the practice final. So solve quadratic equations by factoring. So in this case, it's not just a simplified thing. We have to find what D is equal to here. Okay, and the hint here is we have that equal sign. So we're going to solve this and then we're going to check. So again, I'm going to do the same thing with this trinomial here. Is I'm going to take the 3 times the -3. So 3 times -3 is -9. And I need factors of -9 that add to +8, but multiply to give me -9. And that would be a +9 and a -1. Okay, because 9 plus -1 equals 8, and 9 times -1 equals -9. So let's split that middle term into a plus 9d minus 1d, or just minus d if you want. Minus 3 equal to 0. And then group it. Okay, so we group this and we group this and factor out a GCF from each of the parentheses. So I can take out a 3d from there, and that gives me d plus 3. And then I can take out a -1 from these, and that gives me another d plus 3. And again, you can check that if you distribute the -1, you should get what we originally had here. And so I can now take out the d plus 3 as just a d plus 3, and then times 3d minus 1. And now at this point, you have factored this quadratic. But what you want to do is you want to use the zero product property. Remember, we talked about that. We call it ZPP. And you want to take each of these factors and you want to set them equal to 0. Okay, and then you'll solve. So I'm going to subtract 3 from both sides. So d equals -3. And another thing that would work, if when I add 1 and divide by 3, d would equal 1/3. Okay, so these should be your answers. And what we can do here is we can check those. So we're going to check. Okay, how do we check? Well, let's check d equals -3 first. So all we do is we plug a -3 back into the original equation. And we see if that equals 0. So -3 squared is 9. 3 times 9 is 27. 8 times -3 is -24. Minus 3 equals 0. So we have 27 minus 27, and that does equal 0. So d does equal -3. And then we can check if d equals 1/3. So we plug 1/3 into d in our original equation. And we see if that equals 0. So we see if we made any mistakes. So 1/3 squared, that's just 1/9. 1/9 times 3 is going to be 3/9, or 1/3, plus 8 times 1/3 is 8/3, minus 3. So we have basically 9/3 minus 3. Does that equal 0? Well, 9/3 is 3. And then 3 minus 3 equals 0. So that was check. So d equals -3 and d equals 1/3 are your two answers. All right, that is chapter 6. Let's move on to chapter 8. And in this chapter, again, you'll be tested on these 5 things. So you'll have 5 questions on these topics. You'll use a graph or a table to evaluate a relation. You'll solve compound and 3-part inequalities. Algebraically, you'll write the domain and range of a function. In an interval, you'll solve absolute value equations and then absolute value inequalities. And I will go through a summary of some of that, because I know some of these things, like solving absolute value equations and inequalities, I'll just kind of go through some of the rules on those when we go through an example. But the first question here is, again, on use a table or graph to evaluate a function. So the directions here say the graph of the function h of x is shown. Find the values h of 2, h of 4, and h of 5. So this is the graph. And let's just recall, Okay, so sometimes people get confused. Are they asking for X or are they asking for Y? And what I like to do is recall that f of X, okay, if I have f of X, that's equal to Y. Okay, so basically, if I have this h of 2 here, okay, remember we can kind of replace f of X with h of X or g of X or whatever, right, of X. This X value is, oops, sorry, this X value is 2. Okay, so the question is really asking you if and when X is equal to 2, what is Y? Okay, what is the Y value? And I shouldn't write the Y's like that because sometimes you guys can get confused. So I should write it as that. So when X, this is saying when X is 2, what is Y? Okay, so we look at our graph and we go over to 2 on our x-axis. What is the Y value here when X is 2 in this function? Well, it's on this dot. So we know that Y is 1. So h of 2 equals 1. What is h of 4? We go over to 4 on our x-axis, and the dot here in our function is at 5. So Y is equal to 5. And then what is h of 5? It is at 4. So these are your 3 answers for that. All right, the next one is solve compound and 3-part inequalities algebraically. So we're going to solve this compound inequality, and we're going to write our answer in interval notation. And I kind of made a video earlier in the semester because some of you guys were confused on what is the difference between interval notation and what is the difference in inequality notation. And I'll kind of I'll kind of go through that here. Let me actually just let me summarize that here. Let me give you some examples. Okay, so summary of an inequality notation versus interval notation. Sorry, you guys can't read that because I'm writing in blue there. Summary of inequality notation versus interval notation. So if I give you guys a graph, okay, it looks something like this. And I have a point here that's at 7. And there's a parenthesis right here. And this graph includes everything to the left, okay, of 7. Your inequality notation, okay, of this versus your interval notation, okay? Well, your inequality notation would be X is less than 7, but your interval notation would be -infinity to 7 with a parenthesis to the left of -infinity and then parenthesis closing it off. If you have a graph that's something like this, let's say this is -3, there's a bracket at -3 and everything to the right of that. Your inequality notation would be X is greater than or equal to -3. But your interval notation would be bracket -3 to infinity with a parenthesis. Okay, and this is just review. Let's say you have something like this. So let's say it is, we have a -3 here and we have a 7 here. And we have a bracket at -3, parenthesis at 7, and everything in between those. Okay, then that would be X is greater than or equal to -3, and X is less than 7. Okay, you could also write that as -3 is less than or equal to X is less than 7. Okay, but the interval notation for that would be bracket -3, 7, parenthesis. Okay, remember we put parentheses when it doesn't include that number. So it goes all the way up to 7, but it, 6.99999, but it doesn't touch 7 ever. but this one touches -3. Okay, so we put a bracket there. And then let's do one more. Let's say I have the same situation. Say I have the same situation. Okay, but this is an or statement. So sometimes I might give you this to start. Okay, so it's x is less than 7 or x is greater than or equal to -3. Well, that would actually, because of the or, it doesn't have to, it doesn't have to include everything in those. So it can include everything over here that's less than 7, and then everything that's greater than or equal to -3. So in this case, this is also, this is also the case where we would have everything from -infinity to infinity. Generally, you wouldn't have to go from this form to the infinity form, but if I was writing this, if I gave you this or statement, it's probably going to ask you, I'll just actually cross this out. It's probably going to ask you for the interval notation. And you would say that it's -infinity to infinity because it does include everything. It includes everything because it's an or statement. The difference here in the last one is this was an and it has to be both of those. So even though that, there's things that are bigger than 7 that are greater than -3, we stopped it here because it's an and. It has to have both of those things. So we only include what they both have. Okay, hopefully that makes some sense. So let's do this question here. They want us to solve this compound inequality and write the answer in interval notation. Okay, so with these parentheses and brackets and all that. And it's an or statement. So that's important. So the first thing that I'm going to do is I'm kind of going to split these up a little bit and I'm going to solve them. So I have -x is less than 2. I'm going to divide by -1. So when I divide by -1, what happens? Okay, well, our sign flips, right? When you divide or multiply by a negative, your sign in an inequality is going to flip. And then this is going to be -2. Okay, or let's do the next one. So we're going to subtract -1. So we have 4x is less than -11, and then divide by 4. So x is less than -11 over 4. And the sign didn't flip there because we never divided or multiplied by a negative. So now what I like to do here is before I give the answer in interval notation, I like to draw this out. So what is negative, where's -2 and -11 over 4? Well, -2 could be, let's just draw it. Oops, I just put a 3, of course. Don't know why I did that. But let's just have -2 here, and it's everything greater than -2 with going to be a parenthesis because this is a greater than, it doesn't have that bar underneath it. So it's everything over here. What is -11 over 4? Well, that would be -2 and 3/4. So that's less than -2. So that's somewhere over here. And that's less than that. So again, a parenthesis and everything to the left of it. Keeping going all the way to -infinity, everything over here to +infinity. So again, this is everything over here to -infinity, everything over here to infinity. So interval notation would be -infinity, comma, -11 over 4, parenthesis. And then when it's something like this, we have to put a union symbol in there. And that means basically or. This is the union symbol meaning or. Our and symbol is like an intersection symbol. That's an and, but we're not going to put it in here this time because it's not that type of a problem. Oops, and why did I just do that? Sorry. So we have -2, comma, infinity. There we go. So this is going to be your interval notation of this one. So again, let me know if you have any questions on any of those going through interval notation or anything like that. So let's continue here. I think the next question is write the domain and range of a function in interval notation. Interval notation again. Okay, so using the parentheses or brackets or whatever. Use the graph to determine the domain and range. So remember domain. Domain is what? Domain is any possible x values. Any possible x values a function can be. What is the range? The range is any possible y values. Any possible y values. So this is our function here. It stops right here at -8, and it stops right here, or sorry, this would be -8, 2, and it stops here at 0, 2. So in our domain, what are the possible x values that this function could be? Well, it's everything. Usually when I do that, I look from left to right. So it's everything from -8, that's a possible x value, all the way over here to 0 for x, okay? And all of these kind of in between, right? So, and these do have a dot here. If this was like an open circle instead of a closed circle, then it wouldn't include -8. We would have to start it with a parentheses. But in this case, because it's a closed circle, we start it with a bracket, -8 to 0, and again, another bracket. Now, what's the range here? Well, the range is your possible y values. And for the range, I'm going to look this way. I'm going to look from bottom to top. And domain was left to right. So the first possible y value it could be is -2. Okay. Now we keep going up and it stops here at 2. So our range would be -2 to 2. And again, interval notation. Number 21 on the practice final exam, solve absolute value inequalities. So we're going to solve this absolute value equation. And in a second here, I will summarize this. But if we remember, if we have an absolute value, okay, this can really either be inside the absolute value. It could either be a positive thing or it could be a negative thing. We know that the answer is always going to end up positive. But inside here, it could be a positive or a negative. So what we have to do here is we have to break this up. We have to break this up into two equations. 2x minus 1 equals 7. That's the original. Or 2x minus 1 equals -7, because it could be positive or it could be negative. Not the thing inside. Okay, the answer is not going to be positive or negative, but this thing over here could be positive or negative. Okay, if that kind of makes sense. So that's how you break up an absolute value equation. Now we have two different equations. Now we solve. So we add 1 to both sides here. We have 2x equals 8, divide by 2, x equals 4. Okay, or 2x equals, add 1 again, -6, divide by 2, we get -3. So our answer here would be x equals 4 or x equals -3. And they might ask you to put that in a comma separated form. So you just say -3, 4. Now let's summarize these. Okay, so let's summarize. Okay, summary of absolute value equations and inequalities. So when we have like the less than or greater than signs and all that. So the first one is if you're given something like what we just had, it's in the form ax plus b is equal to, let's say, k. Okay, then you have two different options, right? You're going to do what we just did. You're going to keep one of the originals, and then you say, or have it as a minus k value there. Okay. Our second option is if this is in a less than form. If it's in a less than, we learned that it's a less than, right? So it's an and statement. Okay, so what you have to do is you also have to kind of have one of them as a negative, but we can write this as a single kind of compound inequality. So we'd have -k less than ax plus b less than k. So all I did here is I took the original thing and I added this negative k is less than to the end here. And then we just kind of solve this. We just keep going step by step until it's solved. And then the third one is if we have a greater than. So if I have ax plus b, and I'll go through an example of some of these, ax plus b is greater than k. So that would mean, remember we had this great or than. Okay, and so this is an or statement. So what we have to do is, again, we break one of them up into the original, and then we say or the other one, but we change it to a less than and a negative. Okay, so that's kind of the three options you have when solving absolute value equations or inequalities. And it's very important when you're doing this. So you have to remember, whoops, that is not how you spell remember. This is already getting a little bit long. So, okay, that's all right. Remember, and again, you don't have to watch it all. Remember to first get the absolute value part. Okay, the absolute value part on one side, okay, of the equation or inequality, and the other numbers on other side. Okay, then you break it up like we did here. Okay, but let's go through an example of when we have this one's a less than. Okay, so solve the absolute value inequality. Write the solution in interval notation. So first of all, you check, is the absolute value part on one side? Is everything else on the other side? And yes, it is. So once it is, then you look at this symbol and it's a less than. And we know that it's a less, what? It's a less than. So it's an and statement. And what we do here is, again, we break it up. We say this is a negative 24 is less than what was on the inside is less than 24. Okay, that's how we break it up. And then we solve this, okay, from basically the inside out. So, you know, you're kind of covering up one of these sides and you're saying, what would I do if it was just negative 8x plus 8 is less than 24? Well, you would subtract 8, right, to both sides. But you also have to remember to subtract 8 over here. Okay, and then you do that step. So negative 24 minus 8 is negative 32. Is less than negative 8x. This goes away. 8 minus 8 is 0. Is less than 16. Now, what would you do if you had negative 8x less than 16? Well, you would just divide by. You would divide by negative 8. But remember to divide by 8 over, or negative 8 over here as well. Now, the trick is, what happens when you divide by a negative? We have to switch the sign. So this is 4, but then this sign flips to greater than. X greater than negative 2. And you can write that, you're going to want to rewrite that as this form. Negative 2 is less than x is less than 4. So we always write it with the smaller number on the left. And then, you know, so we would never really leave it in this form. You know, where we have the greater than signs, we kind of we put them in less thans, but you got to make sure when you do that that the value here, not the value, the inequality symbol still opens up to the same things. So I flip this around, but notice here x is greater than negative 2. This sign is still opening, right? It's eating the x, right? If you guys remember maybe from middle school when you guys first learned this on the alligator. Right, it's eating the bigger number or whatever, sort of thing. Maybe your teacher taught that, maybe they didn't. Maybe you're like, what is he talking about? That's just what my teacher said. They kind of drew some teeth on here, and then they said, oh, it's eating the bigger number. Anyway, but this sign is opening to the 4 since still opening to the 4. So I didn't change anything. Now, this would be inequality notation. They want interval notation. And again, what we would do here, whoops, I was starting to write a bracket, but it would not be a bracket. It would be a parentheses. And that's because I don't have the bar underneath here. So it would be -2, comma 4, both in parentheses. All right. Chapter 10. So these, this is probably the chapter that you'll have the most questions on. So this is on radicals. Okay, so I'm going to go through a few of these questions, but you'll have questions on all of the topics here that I list for chapter 10. You'll have at least one question on each of those. So the first kind of question that I'm going to go through is evaluating radical expressions. So evaluate the expression by hand if possible. And then variables represent any real number. So we see here that this is a cube root of 64y cubed. Okay, so basically we need 3 of the same things that multiply to give me 64y cubed. Okay, and you know, we've been through perfect squares, perfect cubes, all that stuff. You guys can look back in your notes if you need to. But this guy, if we took 4y times 4y times 4y, that would give me 64y cubed. But then we're taking the cube root of that. So the answer is just 4y, because that's the thing that we need to multiply together to get me what's on the inside here. So we need 3 of the same things to get that answer. If this was the square root of 64y cubed, then it would be, it would be 8. It would be 8, and I could take out a y, and we would have y left over. Okay, but that's not the question. But I will say, okay, I will say that you guys did have some rules here. So we had this even power, and if you have an even root, okay, well, what happened? Okay, and this is with variables only. Okay, with variables only. Okay, well, remember, okay, if I just have a square root of 25 or something like that, we know that that's just 5. Okay, I didn't have any variables in there. Okay, but if I have the square root of x squared, okay, I actually have to put parentheses around that, or not parentheses, sorry, I have to put absolute value bars around that x. Okay, so if I have a variable in here and I have an even power and an even root, okay, and they match, those need an absolute value. So these two have to match. The index here, the 2, right, of a square root has to match here. And that's only for even things. And because, you know, that's because this x, I don't know what it is. Okay, I don't know what x is. But when I would take it out, it has to be a positive thing. So it has to be an absolute value of x, right? So if I have something like the square root of x plus 3 squared, I also need a absolute value or absolute value bars for that. Okay. This one I didn't need absolute value bars for, even though we had the variable y in here. I didn't need that because it's not an even power and it's not an even root. Okay, that was an odd index, right, or an odd root. Okay, it's an odd power. So I did not need that. Okay, and then I didn't need it here because when I took out, so when I did this example, the square root of 64y cubed, I took out an 8 and I took out a y. Okay, but I have a y left over, so I didn't take everything out. Okay, and this was a even root with an odd power. I didn't need an absolute value. So hopefully that kind of makes sense. I don't know if you're going to run into anything where you'll need an absolute value on your final, but I know that that was kind of an issue sometimes on your chapter 10 test. But I would say you'll probably not need an absolute value on your final. All right, question 33 on the practice exam, adding and subtracting radical expressions. So if possible, simplify the following expression, assume all variables are positive. I got a lot of answers. I remember back to chapter 10 on tests where, people said that there was no real solution, or you couldn't simplify this, or whatever it said. Well, you have to break these down all the way to see if you can simplify them. Okay, so we learned that in order to add and subtract rational expressions, you have to have the same radical, or you have to have the same radicand, the thing inside the radical. Okay, so what I have to do here with 25x squared, okay, I have to break this down. What is it? Well, I can take out a 5 here, right? Square root of 25 is 5, right? This breaks down into square root of 25 times the square root of x. So I can just say that the square root of 25 is 5. I can keep that square root of x. Okay, square root of 36x is the square root of 36 times the square root of x. So this is plus 6 square root x. Now your radicands are the same. We have a square root of x, okay, or the radicals. And what I can do here is that could be my common factor. You can also think about it as a like term. And then what I can do here is I can just add the 5 and the 6. So that's just 11 square root of x. Okay, now it would be completely different, right? Completely different if this was multiplication. Okay, then I could just multiply those. So if I had the square root of 25x times the square root of 36x, okay, what I could do is you could still break it down if you want first, but you could also just multiply these. Okay, so you could just take 25 times 36, that's 900. And then x times x is x squared. So you'd have 9 square root of 900x squared. But the thing about this one, again, is the square root of 900, that actually comes out, that's 30. But then we have a square root of x squared. So that would be 30 with an absolute value of x when you take out the x in there. So we don't have to put an absolute value in the 30. We would need an absolute value on the x. So completely different question if it's multiplication. All right, number 34 on the practice exam was to solve the equation symbolically and check our results. So we had the square root of 2y plus 1. Square root of 2y plus 1 equals 7. And what we did here is we recognized that, oh, this square root is already alone on one side of the equation. So what I can do here is I can square that side. So I can take all of this and I can square it, and I can also square this side. Now you can only do that if the radical is alone on one side of the equation. So if I had something like the square root of 2y plus 1 minus 5 equals 3, the thing I would have to do first is add the 5 to both sides. Then I could square both sides. Okay. So let's do that. Let's square this. Now, when I square a square root, what happens? I'm just left with what's inside of the radical. So 2y plus 1. And this 7 squared is 49. Okay. Now, don't get this confused that we need a plus minus. Remember, we only need a plus minus if I square root. If I square root the side. So some people were getting that incorrect. They were giving me 2 answers for these. You don't hit, there isn't 2 answers. Okay, that's only when we square root it. Okay, so if this was, if this was y squared equals 49 or something like that, I would square root this, and then y would be equal to plus or minus 7, right? But again, we're not doing that. So I don't need 2 answers here. I'm squaring it. So let's subtract the 1. So we have 2y equals 48. And divide by 2, that's 24. So simply y is equal to 24. And then I do ask you to check this one. I might not check all of these, but this one's good to check just in case. So we have the square root of 2y plus 1. Does that equal 7 when y is 24? Well, 2 times 24 is 48, plus 1 is 49. It's a 9. It's a really bad 9. But that's 7 equals 7. So yes, that checks out. All right, 37 is on the Pythagorean theorem. If we remember the Pythagorean theorem, okay, that says a squared plus b squared equals c squared. So the sum of the squares of the two sides of a triangle equal the square of the hypotenuse. Okay, and we normally label the hypotenuse as c, right? So this is the hypotenuse. It's the angle, or that's the side that's opposite of the 90-degree angle, right? Our right angle, and then the two sides are a and b, or b and a. It doesn't really matter. But in this right triangle, find the length of the side not given. So we have a equals 8, c equals 17. What is b, right? We need to know what b is. So this could be, you know, a is 8, this is 17. We need to know b. Well, what we do here is we take our Pythagorean theorem and we substitute. So a is 8. So I use parentheses. So 8 squared plus b squared equals 17 squared. 8 squared is 64. And 17 squared is 289. Then I subtract. 289 minus 64 is 225. And now I square root. So b is equal to 15. Now, some of you might be like, well, why don't we have b equals plus and minus 15, right? Why isn't one of them 15? Why isn't the other one minus 15? Well, that's because you can't have a side that's negative, right? You can't have a negative distance. Okay, so in this case, we don't do a plus minus because we're just finding a side length. So b equals 15. All right, 38, last example in chapter 10. Simplify square roots of negative numbers. So expressed in terms of I. So this is where we have our complex numbers or our imaginary numbers. So recall here that I is equal to, or the imaginary number I is equal to the square root of -1. I squared is equal to negative I, and I to the 4th is equal to 1. Some of you might wonder, where are we ever going to use complex or imaginary numbers? I actually did get an email from one of you about that. And that is typically, and you can Google that, right? Where are complex numbers used? And you'll find a whole bunch of different things. But the main area they normally use them is the electronics field. So maybe in your phones, in wiring, and different things like that. To make some of those things, they actually have to use complex numbers. I don't really know how that all works, but I know that they do have to use it. So that's kind of interesting. But let's express this square root of -12 in terms of I. So I can break this up, right? We have kind of that product rule that I've been using. I haven't mentioned that specifically what it is, but I can take the -12 and I can break it up into -1 times 12. And then I can split that up like this. And then I know now that the square root of -1 is the complex number or the imaginary number I. But also, actually, before I do that, I can also break up the square root of 12, right? Because that's the square root of 4 times the square root of 3. And so I have I times what? Well, the square root of 4 is 2. And then the square root of 3. So how I would write that is 2i times the square root of 3. So you always put the number in front of the I value. Okay, so 2i plus the square root of 3. All right, chapter 11, some key concepts here. So again, I'm going to ask you questions on all of these concepts, but I might not go through the examples here. So, but let's go through finding the minimum of, what did I want to say there? Not the word of, that's for sure. Okay, I was confusing myself there. This should be finding the minimum or maximum value of a quadratic function. Okay. In this case, I'm going to ask you, let me just change this one. I'm going to ask you in number 40 for the maximum value here on your practice final. Find the maximum y value on the graph of y equals f of x. Well, we know if we have a graph and it has a squared term in there and nothing else that's a higher number power, that's going to be a parabola or a quadratic, right? We remember we had a quadratic or a parabola like this, where you have a vertex, right? Your vertex is right here, or it could be kind of a upside down. So this one would be a U shape. This could be an upside down U where your vertex is here. Okay. And we also learned in a quadratic, we learned that this is the general form of a quadratic. F of x equals ax squared plus bx plus c. And if the a value was negative, okay, if the a value is negative, or if a value is less than 0, then it's going to be this upside down U shape. And if a is positive, then it's going to be this U shape. So what does that mean? That means the maximum y value is going to be, it's going to be this one, right? Because what is the a value? The a is -1, and that is less than 0. So it's going to, if I were to graph this, it would be this upside down U shape. Okay, so I'm trying to find the maximum y value, and that's the y value of your vertex, right? It's the y value of your vertex. And I said a couple of different things about these. In a quadratic, the x value is actually the formula -b/2a. So I could find my b value and my a value, take -b/2a, that would give me the x value of the vertex. The y value of the vertex is substituting that x value that you find back into your function to find the y value. So it's f of -b/2a. So let's do this example. So again, I said a is -1, b is 4, c, just because we don't really need it, is 7. But the x value of the vertex, let me restate this, the x value of the vertex is -b/2a in any parabola, right, where you have the equation. So in this case, what is that? Well, in this case, that is a negative. What is b? B is 4 over 2 times a. A is -1. So it's -4 over -2, which is 4 over 2, right? Negative divided by a negative, which is 2. So the x value of this vertex here is going to be 2 comma something. Okay. Let's find the y value. Okay, the y value of the vertex is f of -b/2a. And we already found that, -b/2a. We found that it was 2. So really I'm taking f of 2 here. So I'm substituting 2 everywhere that we see an x into our original equation. So in this equation, -x² plus 4x plus 7, I'm going to substitute a 2. And I always use parentheses. So that's going to be 2 squared is 4. So I have -4 plus 4 times 2 is 8 plus 7. And -4 plus 8 plus 7 is 11. So f of 2 equals 11. So my y value of the vertex is 11. So what is the maximum y value on the graph? It is 11. All right, number 41 on the practice final. Compare the graph of f of x to the graph of x squared. Then sketch a graph of f of x or y equals f of x and y equals x squared on the same plane. So this is our f of x function. We need to know how that compares to y equals x squared. And then we also need to graph this. Well, if I'm graphing y equals x squared, okay, remember, I can just choose values for that. So let's say I have -2, -1, 0, 1, and 2. If I plug in -2 for x, I'm going to get -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. So I can easily graph this function by just picking values. You can also use Desmos if you'd like. We did that quite a bit. So it looks something like that. Okay. Now, before I am going to go through the rules of this, let me summarize them. Okay, so let me summarize this. So how does this move, right? Does x plus 5 squared, is that going to move it left or right? Is the -3, is that going to move the points up or down? Is the 1/3 going to make the graph wider or narrower? Well, let's recall some of those rules. Okay, so recall, if I have the graph y equals x squared, that's just our base function. Okay, that's our base function for a parabola. Okay, and then when I add or subtract things inside the parenthesis or outside or next to the parenthesis, we need to know how that changes the base function. So if I have y equals x, let's say plus h, so say an h value squared, and it's inside the parentheses, okay, what does that mean? That's going to mean the values in the graph are going to shift. They're all going to shift left. Okay. If I have y equals x minus h squared, we learned that all the values are going to shift right. If I have y equals x squared plus k, that means that the values are going to shift up. If I have y equals x squared minus k, that means all the values are going to shift down. If I have, let's say, I can't do this without kind of an example. If I have y equals 1/3 x squared, okay, that means that the values that this graph is going to be wider than x squared. But if I have y equals 3x squared, this is actually going to be narrower than x squared. So if I had 1/3 x squared, I would need to draw this wider. If I had y equals 3x squared, this would be narrower or closer to the y-axis. So how does this one change it? Okay, how did these values change it? Well, x plus 5, I start always on the inside of the parentheses for some reason. Okay, maybe it's because I do it for order of operations, but we don't really have to do that here. X plus 5 would mean that this is going to shift left 5. So all the values are going to shift left 5. The -3 out here means that the values are going to shift down by 3. And then the 1/3 means that this graph is going to be wider than x squared by a factor of 3. So what could I do here? I could take the vertex of this parabola and I could shift it left 1, 2, 3, 4, 5, and down 3, 1, 2, 3. So the vertex, you know, I can just move. This is still going to be the vertex as it was here. The rules shifting it wider or narrower, these last two don't really apply to the vertex. Okay, but then what I do here is I do want to find the other points. And really what you want to do here is you can either use Desmos or you can make a little table. And that's kind of what I would do here is I would look at this guy and I would look at, well, what are some x values maybe that could give me nice whole numbers? Okay. And, you know, you can kind of test that out. If I put a 1 in here for x, is that going to give me a whole number? It possibly could, but 1 might actually be way, or it could possibly be off the graph. But 1, let's see here. Well, one actually might work. Okay, that's not what I was thinking. But if x is equal to 1, I would have 1 plus 5 is 6. 6 squared is 36. 36 divided by 3 is 12. And then 12 minus 3 is 9. So you can check that yourself, plugging in 1 for x here. You should get a 9. So in our graph, actually, let me do this one in red. Let me erase. Let me erase that vertex as well. So the new vertex was left 5, down 3. And I just had a point of if x is 1, y is going to be equal to 9. So 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops. Okay. And I think that works. Let's do what I had in mind, actually. So we already did, the vertex. The vertex, I'll just call it V, was at -5, 3. Or not -5, 3, -5, -3. And we can tell that if we plug in -5, I get -5 plus 5 is 0. So 0 squared is 0, 1/3 times 0 is 0, 0 minus 3 is -3. But let's choose -8. And a -8 is actually going to make this -3 squared, which is 9. 1/3 times 9 is 3. 3 minus 3 is 0. We're going to have a point here at -8, 0. Get that right. And then -2, I don't know if I can fit it here without it's kind of trying to draw or change my color there, but -2, that's also going to end up at 0, right? Because it makes this a 9, and then 1/3 times 9 is 3. 3 minus 3 is 0. So -2, 0. So this graph is going to look something like this. It's best I can draw it. Try to imagine that that was actually going through the point 1, 9 right there. Okay. So that's how we would graph it. Again, the most important thing probably is to remember all of these rules here. Okay, let's solve an application problem now. So number 43, and a lot of you guys on your chapter 11 test had this one incorrect, so I wanted to go through this. Solving applications with quadratic equations. When a person throws a ball in the air, it follows a parabolic path. So it's a parabola that opens downward as shown in this figure. Suppose the ball's height in feet after t seconds is given by this formula. So it's the height after t seconds is equal to -16t squared plus 48t plus 4. If possible, determine the times when the ball was at a height of 24 feet. So that would be at 2 different times. It would be right here and right here. Okay, so you're going to have 2 different times, 2 possible answers, right? Because if you throw something in the air, right, like way up in the air, it's going to reach a height of 24 feet twice, because it's going to follow kind of that parabola form, right? So what I would do here, this formula, this is h of t. What does that mean? That means the height after t seconds. Well, they gave you the height. Okay, they gave you 24 feet. So what you do here is you plug 24 in for h of t. And then you solve for t, because that's going to give you the times, determine the times when the ball was a height of 24 feet. So some of you guys I noticed on your chapter 11 tests were plugging in 24 for t. You wouldn't do that. You wouldn't do that because t is the time. H of t is the height at a given time. So you plug 24 in, h of t becomes 24. Okay, think of that as your y value. You're trying to find the x value. Okay, because if you kind of draw this out here, right, and it looks like a graph, this is your x-axis, this is your y-axis, you know the height, right? You know that this is 24 feet. You're trying to find the 2 times. Okay, you're trying to find the 2 times right here. So let's solve for t. So what would I do? Well, let's actually, let's set this to 0 and let's subtract negative 24. So I'd have negative 16t squared plus 48t. 4 minus 24 is negative 20. Now at this point, we had learned in chapter 11 to do the quadratic formula, and that's probably what I would suggest in this case. You could also maybe factor. So you could, you could divide all these things by a greatest common factor, and then you could factor, but I'm just going to use quadratic formula. Okay, so we remember that the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, my a value is that negative 16, my b value is 48, and my c value is negative 20. So let's do that here. So I have negative 48, right, because minus b, plus or minus the square root of b squared, so 48 squared, minus 4, minus a, negative 16, minus c, negative 20, all over 2 times a, so 2 times negative 16. And when you do this, so what I would recommend is type in all of this just as it looks in your calculator, using parentheses. And what you're going to get there is 1024. And then 2 times negative 16 is negative 32. Now take the square root. The square root of 1024 is actually a nice whole number that gives us positive 32. And so what I'm doing here is I have 2 different things. I have a negative 48 plus 32 all over negative 32. And I don't really need this 0 equals this anymore. But this ends up being a 1/2. So negative 48 plus 32 is negative 16. Negative 16 divided by 32 is equal to, I don't need this 0 here. That equals negative 1/2. And then negative 48 minus 32 over negative 32. That is going to give us negative 5/2, actually. Wait. Nope, hold on. Negative 48 minus 32 divided by negative 32. Yes, that actually does give us, oh, I see where that, okay. This is positive 1/2. And then this gives us a positive 5/2 or 2.5. So what times is this going to be 24 feet up in the air? It's going to be 24 feet at 0.5 seconds and 2.5 seconds. And that kind of intuitively makes sense, right? If you throw a ball way up in the air, okay, 40 feet up in the air, it might take, 3-ish seconds to reach the ground. I don't know. Go out and try it with your friends. Okay, and you can take still frames of when the ball is 24 feet in the air or whatever. Okay, try to figure that out. All right, question 45. Using the quadratic formula to find x-intercepts of a function. So again, there could be instances, right, where a parabola does not have any x-intercepts. And this would be when we would have no solution. Okay, there's also, so no solution or no solutions. There could also be a time where your vertex of your parabola just touches the x-axis. And this would be one solution. And there could be times where your parabola crosses the x-axis in 2 different points. And those are 2 solutions of that function. Okay, so we know that quadratics, when they have a solution, it's a point, right? They're points, they're x, y points. So that's why it says use the quadratic formula to find x-intercepts on the graph. And when we answer it, we're going to answer it in kind of point form. Okay, so using points. It also may just say x equals something, and I'll kind of show that to you here at the end. So we just went over the quadratic formula on the last problem, but let's define a, b, and c first. So a is -5, right? And I'm going from that our standard form of a quadratic is y equals ax squared plus bx plus c. So a is your coefficient in front of x squared, b is your coefficient in front of x, that's -6, and c is your last number there. In this case, it's 8. Again, make sure that's in order from greatest exponent to least. And if they don't have any exponents, list that term at the end. So let's plug that into our quadratic formula, which says -b plus or minus the square root of b squared minus 4 times a times c all over 2a. So, and I need to change this. All of these really should be x's, right? Or t's. These aren't zeros back here anymore. Once I subtracted that 0, these should all be t's. Okay. But anyway, let's go back to this question. -b, we have a -6. So minus a -6, that's kind of why I use the parentheses here, because I'm substituting in a negative. I just have to remember that this minus on the b stays. B squared is a -6 squared minus 4 times a, which is -5. C is 8. All over 2 times a, 2 times -5. So this is going to give me a positive 6, because a negative times a -6 is positive. Plus or minus, we have 36. And so again, I would just recommend typing all this in on your calculator and getting a value. And the value you should get there is 196 all over -10. And that's going to give you, well, the square root of 96 is a nice whole number, 14. And then you have x equals 6 plus 14 divided by -10 is equal to -2. And you have 6 minus 14 divided by -10 is -8 over -10, which is a positive 4/5 as it reduces. So really your two answers are -2 and 4/5. Now they might ask you for this form, or they could also ask you for the 2 points. So that would be, -2, 0 and 4/5, 0. Obviously this is not to scale here, but -2, 0 and then 4/5, 0. So either or, I don't know what form is going to ask you for. All right, last example on chapter 11, and then we'll move on to chapter 7, and we'll just have a few more, and then we'll wrap it up. So solve quadratic equations that may have complex solutions. Okay, and again, a quadratic that has complex solutions looks like this. When we had this should be no real solutions. This would be one real solution. This one would be 2 real solutions. Okay, complex solutions are when the quadratic does not touch the x-axis. That's when that occurs. So that's where we need to know this. And then we'd also need to write the complex solutions in standard form, which we remember is a plus bi. So we are going to use well, you know what? I have not given you an example of completing the square yet. So what I'm going to do here is I'm going to complete the square You can also use the quadratic formula. Let me actually use the quadratic formula first, okay? So I'm going to use the quadratic formula first because that's what we've been doing, and I'm just going to quickly do that. So A is 1, B is -1, C is 5. Go back to the last two questions if you need practice on quadratic formula. But this is going to be x equals negative b, so negative times -1 plus or minus the square root of b squared, -1 squared minus 4 minus 4 times a times c all over 2 times a. So this is going to be 1 plus or minus the square root of -19 is what that all ends up being inside the radical, divided by 2. And in this case, the -19, we know that we can pull out that -1, which is an I value. So it's 1 plus or minus I times the square root of 19 all over 2. And that breaks up into 1/2 plus I square root of 19 over 2. And 1/2 minus I square root of 19 over 2. So that's what we should get here. And I'm going to complete the square. And we remember from completing the square that there was a really important step to that. So when we complete the square, first thing we do is we subtract this 5 over. And I need to add in something. Okay, we remember that I needed to add in something here and here. Well, what is that something? And we remember from completing the square that that something is b over 2 squared. Well, what is the b value here? The b value is -1. So it's -1/2 squared, which is a 1/4. So if you need some practice on that, go back and look at that. But you can, you know, the 1/4 would be that b over 2 squared value. Now, I don't think I had any examples on when this value was a 1/4. Okay, but when we take this trinomial and we're trying to, you know, put it in a factored form, okay, that would end up being x minus 1/2 times an x minus 1/2. How do I know it's a 1/2? Because actually this number is always this guy on the inside of the parentheses. That's a little trick there when you complete the square. But I can also write that as x minus 1/2 squared. -5 plus 1/4 is -19 over 4. You guys can check that on your calculator. Now, what's the problem with that? Well, I need to square root this to solve. So when I square root, I'm taking the square root of -19 over 4, but I have to plus or minus that. Now I can't take the square root of a negative. So I have to have that. This is where that complex number comes in here. So I have to pull out an I value. And in this case, because it's over 4, I'm actually going to pull out an I over 2. So this is going to be I over 2 plus or minus I over 2 times the square root of 19. And then I can take that 1/2 and I can put it over here. So 1/2 plus or minus I square root of 19 over 2. And we notice that we get the same thing that we did earlier, just one is plus, one is minus. So we still end up with that 1/2 plus I times the square root of 19 over 2 and 1/2 minus I square root of 19 all over 2. Okay, and you know, you notice here this step that I kind of put the I and the 19 together on the top of the fraction. You can do that because this is really the square root of 19 over 1. So it's I times the square root of 19 all over 2 times 1, or just 2. So some of you might have gotten confused on that step, but you know, notice here this step where I did that, and then I just added the 1/2 over to put it out front. So either way, using the quadratic formula or completing the square, you're going to end up with the same answer. So if you do need more practice on completing the square, go back to chapter 11 and do some of those questions that were on completing the square. All right, chapter 7. So here are some key concepts that you'll need to know. Again, you'll have one or more questions on all of those on the final. But let's do an example of finding values of a variable that make a rational expression undefined. So find any values of the variable here, and the variable y is y, that make this expression undefined. Well, when is an expression undefined? When it's a rational expression, right? Well, it's undefined when your denominator is 0, right? So we can never divide by 0. So what do? I take the denominator and I set it equal to 0. And I do that because that's going to give me all of the values of y that make this denominator 0. Okay. And so I can subtract 1 to both sides and divide by 7. So I have y equals -1/7. That's the value, -1/7, that makes this denominator undefined. You could even check that. Okay. You could check, plug in -1/7 for y. Does that equal 0? Well, yes, because 7 times -1/7 is -1, and -1 plus -1 equals 0. So what does that mean? It means -1/7 makes the denominator 0. And that cannot be. So that's the value of the variable that makes this expression undefined. Let's do number 49 on the practice final exam. This is simplifying rational expressions. So again, in order to simplify, we have a addition or subtraction here, in this case, subtraction between these. Now, this would be, again, a totally different problem if it was being multiplied like this. Okay, so if it was x squared times 5x, and then a 4x times, let's say, a -20, totally different problem, because this would be 5x to the third over -80x. And what we could do here is start canceling, right? Because this would be 5 times x times x times x over -5 times, let's see, what's 80 divided by 5? 16. Let me actually do it this way. Instead of -5, I'll do 5 times -16. Or you could have, you could have a -1 times 5 times 16 times x, and then we could start canceling, right? So I could cancel an x out, I could cancel a 5 out, and I'm left with x squared over -16. Now, that's not this question. You have a subtraction, so you can't just go ahead and start canceling x's. You can only cancel when you have it all in factored form. So we have to factor this top here, x squared minus 5x. So you ask yourself, what can you take out of that? Well, you can take an x out. So if I take an x out of x squared, I have an x. If I take an x out of 5x, I have a 5. And here I can take a 4 out, and I'm left with x minus 5. Now they're all factored and they're all being multiplied. I can cancel the x minus 5s, and I'm left with x over 4. All right, multiply, divide, and simplify rational expressions. Remember, when you have division in here and you're simplifying, we learned in chapter 7 that you keep, change, and flip, right? So I'm going to keep this first expression, x minus 7 over 2x. I'm going to change division to multiplication, and I'm going to flip the second expression to 6x over 7 minus x. Now what I want to do is I want to write these out so that I can cancel factors. So I'm going to rewrite this as x minus 7 over 2x. times 2 times 3 times x. It's the same thing as 6x. Now 7 minus x, this is where we had that trick where you can factor out a -1 and you get the same factor here, the x minus 7. Try that. If you distribute -1, you get a negative x and you get a positive 7, which is the same thing as 7 minus x. So now you can go ahead and cancel the common factors, either diagonally or up and down. So x minus 7's cancel. We have a 2 that cancels. We have an x that cancels. And all you're left with here in the numerator, when you multiply across, is the 3. All you're left with in the denominator is -1. And we know 3 over -1 is -1/3. All right. Let's see how many more. 2 more, I think. So number 53 is adding and subtracting rational expressions with unlike denominators. So if we have unlike denominators, whoops, it's doing that drawing thing again. I had to have one of those, right, for the final exam review when it starts randomly drawing like that. Unlike denominators, we need to make a common denominator, right? And the way that we did that was finding the least common denominator of your 2 denominators. So what's the least common denominator of 6x and 7x? Well, we learned that we could write those out in the form of prime factors. And then we need we need the greatest number of those in here. So we need a 2, we need a 3, we need a 7, and we need an x. Okay, so your LCD in this case is actually 42x. Okay. If you had a 6x and a 7x squared, your LCD would be 42x squared because you need that x squared in there. Okay, if you had 10x squared y and a 25 x cubed y cubed, your LCD there would be 50, because 10 and 25 both go into 50. That's your least form. And then x cubed y cubed. Okay, so hopefully you kind of know how to find the LCDs there. Different than a greatest common factor, right? Greatest common factor of these two would be an x. Greatest common factor of these two would also be an x. Greatest common factor of these would be a 5x squared y. All right, now let's get back to this. So let's try to add these. We need to get that common denominator. So I left a little room there. And what I do is I multiply it, the denominator and the numerator, by what I was missing to get that LCD of 42x. So to get a 42x, I have to multiply 6x by 7. And I do the same thing to the numerator because I'm really multiplying it by 1. 7 over 7 is 1. So I'm not changing this, I'm just changing its form to get a common denominator. And a 7x, I have to multiply by 6. Again, top and bottom, because I'm multiplying by 6 over 6 or 1. So now this is going to be 7 times x is 7, or 7 times 1, excuse me, is 7. 6x times 7x is 42x. 2 times 6 is 12. 7x times 6 is 42x. Now I can add the numerators because I have a common denominator. So I add the 7 plus the 12, keep that denominator 42x. 7 plus 12 is 19 over 42x. All right, the last question, I believe, is solving this rational equation here. Kind of the same thing, or you could do the same thing as what we just did. But in this case, there's a little bit of a shortcut, and that's because this is equal to 0. So what I could do here is I could take this 1 over x plus 6, and I could add this entire expression over to the other side. So it would be 1 over 2x equals 1 over x plus 6. And now I can cross multiply. Remember, if we had it in this form, we can cross multiply. So I can take 1 times x plus 6 set it equal to 1 times 2x. And so that's just x plus 6 equals 2x. Subtract this x over to the other side, and you have x equals 6, or 6 equals x. Okay, and you could even check that. Okay, you could check that, plug in 6 for x. Oops, I just put an equal sign. I meant to put a minus sign. So 1 over 2 times 6 minus 1 over 6 plus 6. Does that equal 0? Well, 1 over 2 times 6 is 1 over 12. 1 over 6 plus 6 is 1 over 12, and 1/12 minus 1/12 is in fact 0. So that checks out. Now, the other way to do this problem, if you don't recognize that you can add the 1 over the x plus 6 over to the other side, and then cross multiply, is to do the same method that we did in the last problem. So the other method, we'll call it method 2, is finding that LCD. So the LCD of these two is equal to 2x times the x plus 6. So what you would do, let me leave some room with these. Is you would multiply all three terms by that LCD. So by the 2x times, oops, let me not do that in green actually, because I'm not checking it. I like to do green for checking and red for other things here. But we have 2x times x plus 6. That's your LCD. And then multiply all three terms by that LCD. And then what you can do is you can cancel. So the 2x cancels here. The x plus 6 cancels here. 0 times this is just going to be 0. So x plus 6. So what do I have left? I have x plus 6 times 1 minus a 2x times the 1 equals 0, because 0 times all this is just 0. So I have x plus 6 minus 2x equals 0. Combine like terms, x and a negative 2x is negative x. Subtract the 6 over. So negative x equals negative 6, and divide by negative 1, and we still get that x equals 6. I just think that this shortcut right here is way easier than doing this method if you recognize it. Okay. Obviously, in this case, we can't really do a shortcut. It's not equal to 0. So I can't just say it's 1 over 6x equals negative 2 over 7x. We cannot put in an equal sign ever. Okay, if it's just a simplify problem, it's just a simplify. We're not finding what x equals. Okay, if we have an equal sign, we're solving for x. All right. Guys, that is everything from intermediate algebra. If you have any questions on your practice final exam or anything else that's going to be, that could be on the final, please let me know. And you can shoot me an email, and we can kind of go over that if you would like. So thank you again for everything. If you have any questions regarding what you need to do during the final week, please let me know. Otherwise, have a great rest of your semester, and it was great being your instructor. So we'll see you.